Today I'm going to talk to you about a number of different equations, electrical equations. It's not all of the equations in electricity, but it's a number of them. So we're going to work through some examples together. I've got some more examples in the comment section, and later on I'll do another video of some more of the equations in electricity. So this isn't the whole of the exam question. It's just parts of the exam questions where we'll have to choose which equation to use. So the three equations we're going to use today are Q equals I times T. We're also going to use V equals I times R and E equals Q times V. So we've got three equations that we're going to use, but what do all the letters mean? So Q stands for charge, and that's measured in coulombs. Capital C. We've got E, which is for energy, and that's measured in joules. We have got V, which is for potential difference, and that's measured in volts. We've got R, which is for resistance, which is measured in ohms, and we've got I, which is for current, which is measured in amps or amperes, A, capital A. So what we're going to do is we're going to look at some exam questions now, and we're going to decide which equation is needed for each of those scenarios. So here's the first exam question. So let's have a little look at it. Let's break it down and see which equation will we need. Now remember, you won't be given these equations in the exam, but it's really important for us to work out from our memory which equation to use in each scenario. So first of all, let's start by reading the question, and I'm going to highlight some of the key things. So, to boil the water in a kettle, 2,400 coulombs of charge pass through the heating element in 200 seconds. Calculate the current flowing through the heating element and give the unit. So first of all, we need to know what we're being asked to work out. So we're being asked to work out the current here. Calculate the current. So we're being asked to work out the current. So the current symbol is I. We're trying to work out what is I, what is the current. The other bits of information we've got is 200 seconds. So that is time. 200 seconds is time, and 2,400 coulombs, and that is charge. Remember, that's Q. Okay, 2,400 coulombs. Okay, so what we're going to do is now we can see which equation to use because we've got Q, I, and T. So what we're going to use is quit. Q equals I times T. So we've got Q is 2,400. Okay, we don't know I, but we do know T is 200 seconds. Okay, so we've got our formula, we need to put in our numbers, we need to work out our answer, and don't forget the units. So we've got our formula. Okay, now we need to rearrange it to work out the answer. We've put in the numbers, we need to rearrange it to work out the answer. So what we're going to do is we're going to do 2,400 divided by 200 will give us the current. Okay, so what I've done there is I've moved the 200 seconds and I've divided it by both sides so that I can work out the current. So 2,400 divided by 200 will give me my answer, which is 12, and then I don't forget the units of current. Current is measured in amps, A. 12 amps is our answer. Okay, so we're going to have a look at another exam question again. We're going to have to work out what formulas to use in this scenario, break it down, and then work it out. So, use the correct answer from the box to complete the sentence. Electrical current is the rate of flow of, is it charge, energy, or power? It's charge. Okay, now here's our question with our formula. Another electrical appliance is connected to a 20 volt supply. The appliance transfers 300 joules of energy. Calculate the charge. So what we've been asked to work out? We've been asked to work out the charge, which is symbol Q. We don't know that. We've been given 200 volt supply, so we know that the potential difference is 20 volts, not 200, apologies, 20 volts. We've also been given that the energy is 300 300 joules. Okay, so now we need to put this into a formula, number, answer, units, scenario. So formula, what connects Q, V and E? Well, we know that E equals QV, Q times V. So we know the energy is 300, so put my numbers in, equals Q, which I don't know, times 20. Now to get the Q on its own, I'm going to divide both sides by 20. So it's going to be 300 divided by 20 gives me Q. So 300 divided by 20 gives me an answer of 15. So Q equals 15. But don't forget the unit. What is the unit of Q? Q is charge. What's the unit of charge? Charge is coulombs, 15 coulombs. So here's another question. Let's have another look at these questions, break it down and work out what it's asking us. So the LDR was placed near a light source. The following results were recorded. Potential difference is 5.5 volts. The current is 12.5 milliamps. Write down the equation that links current, potential difference and resistance. So what equation links these three things? Well, current symbol is I, potential difference symbol is V, and resistance symbol is R. What links these? V equals I times R. Potential difference equals current times resistance. Now calculate the resistance. So we're being asked to work out the resistance. We don't know the resistance, but we do know that the potential difference is 5.5 volts, and we do know that the current is 12.5 milliamps. So what does that mean, milliamps? Well, that means it's 1,000th less than an amp. So what we need to do is do 12.5 divided by 1,000 gives me 0.0125 amps. Okay, so we need to make sure that we're using the proper unit before the standard unit before we continue. So formula, number, answer, unit. So the equation we're going to use is V equals I times R. We're going to put the numbers in. We know that the potential difference is 5.5 5.5. We know that the current is 0.0125 times the resistance, which we don't know. Now, to get resistance on its own, we're going to divide 0.0125 on both sides. So we'll get resistance equals 5.5 divided by 0.0125 gives me an answer of 440. So my resistance is 440, and then I just need the units of resistance, and the units of resistance is ohms. To another question. So let's break the question down again. The circuit is connected for 300 seconds. The total current in the circuit stays at 0.56 amps. Calculate the charge flowing. So this time we've been given the equation. So what we need to do is follow the same system. Formula, number, answer, units. So we've got charge equals current times time. We know that the time equals 300 seconds. We know that the current equals 0.56 amps, and we're being asked to work out the charge. So what we're going to do is put our numbers in. So charge equals 0.56 times 300. Work out our answer. Equals 168. Is our charge, and we don't forget our units of charge is coulombs. Right? Okay, here's another question. Same thing. Read the question carefully, highlight the key elements in it, work out what we need to do, break it down. So let's have a look. The potential difference supplied by the battery is 4.5 volts. Calculate the total energy transferred in 300 seconds. We've been given the equation again. Energy equals charge flow times potential difference. So we know that E equals Q times V. Okay, so we're being asked to calculate the total energy transferred. So we don't know what E is, don't know what the energy is. We know that the potential difference is 4.5 volts. We know that the time is 300 seconds. Okay. So we're being asked to work out the energy transferred equals charge flow times the potential difference. But where do we get the charge from? Okay, we don't have the charge. We've got E, V, and T. We need Q to work it out. Okay, so how am I going to work this out? So let's go back. It says use your answer from part D. So we go back to part D and we know that the charge was 168 coulombs. So we know that Q was actually 168 coulombs. So an energy transferred is the charge flow times potential difference. So we know that the charge flow is 168. So E equals 168 times 4.5 volts. So the energy equals 168 times 4.5. Give me an answer of 756 joules. Okay, so there's some of the examples of some of the questions on the worksheet that is in the comments or attached to the lesson. What I want you to do is work through the rest of them. Use the ones I've given you already to help you understand. Work through the rest of the questions following the same system. Highlight the key information. Work out what you know. You've got 3 formulas. It's one of those 3 formulas. Okay, break it down. What do you need to work out? Follow the system. Formula, number, answer, units. Make sure you're really clear with how you're laying it out. Show you're working out. Don't go straight to the answer. Show you're working out, because there's marks for every step of the way. Okay? Good luck. Have a go at it. See how you get on.